We will use the same ambulance response time scenario but extend a factor in this case, because here we are talking about two-way ANOVA. As we said earlier, an ambulance is expected to reach the caller within 10 minutes. So let's assume we collect the response time by ambulances in 3 major cities. Now let's say that each of these 3 cities is being served by 2 ambulance agencies. So now we have to find out if there is a statistical evidence to believe that one of the cities and one of the agencies is better than others. In this example, we would be analyzing the response, which is ambulance reporting time, with respect to 2 factors, that is city and agency. Response data is continuous and the factors city and agency are categorical in nature. Also, the design is balanced as each subgroup is equal in size. In this case, it's 5, because each city has got 10 data points and within each city there are 2 agencies. So the subgroup size happens to be 5 and equal. So that's why we use two-way ANOVA. Now before we get into the statistical inferencing using two-way ANOVA, we need to form our hypothesis. And for that, first we need to calculate the average time for the 3 cities and 2 agencies. Now based on the average response time, it appears that city 1 is at the lowest response time, that is 13.04. And coming to agency A seems to be at the lowest response time of 15 minutes. Now based on these numbers, we would choose our alternate hypothesis, which would be that at least 2 of the cities and 1 of the agencies have a response time different from others. And null hypothesis would assume that the mean reporting time is similar across the cities and agencies. Since the agency factor levels are present in all the city factor levels, there is a possibility that the response at a factor level may depend upon the level of other factor. Like, we have got 2 agencies. Let's say agency A, there is a trend in terms of how the data point is distributed, and this kind of a trend we will see across all the 3 cities. Or we have, let's say, city 1, 2 and 3. Now when it comes to city 2, there is a trend, and this trend we will see across agencies A and B. Now this effect is what we call the interaction effect. In two-way ANOVA, this value is calculated in the Anova table over and above the stats for factor and error, which we have already seen in one-way ANOVA. And since there are 2 factors, the confidence intervals in two-way ANOVA will be calculated for both city and agency separately. Let's look at a typical two-way ANOVA setup in Minitab. We'll find two-way ANOVA under stat, then we have ANOVA, and within that we will find two-way ANOVA. First, we select the response time or reporting time under response and assign one of the factors to the row factor and the other to the column factor. We need to select display means for getting the confidence interval plots for the means. We select confidence level at 95%, and under graphs I prefer to select box plots of data. It is optional, but it helps to visualize the data distribution. Now in two-way ANOVA, this is how the Anova table gets displayed. We had seen in the previous sections of this video tutorial that for one or more factor levels to be significantly different, the first criteria is that the between variance, which is given by mean sum of squares for the factor, it should be greater than within variance, which is given by mean sum of squares for error. Now in this example it holds good, because for cities it's 64, which is greater than 0.34, which is the mean sum of squares for error. And for agency, 15 is greater than 0.34. Now coming to p-value, for both cities and agencies, it is less than 5%. 5% is the level of significance in this test and is given by 1 minus confidence level, which we assigned 95% at the beginning of the test. So this means that our data sets don't align with the null hypothesis, in which we said all variances are equal. So we end up rejecting the null hypothesis and accept the alternate hypothesis that at least 2 of the cities and 1 of the agencies have a response time different from others. As was the case with one-way ANOVA, second set of stats to interpret in ANOVA is the confidence interval. Now this would help us to understand the interval range in which the individual subgroups are varying, and also how the means differ across the subgroups. So if the confidence intervals overlap, then the chance is that statistically there is not much evidence that separates these subgroups, which means they are similar. But if the intervals do not overlap, and if the p-value is also less than the test significance level, which we have taken at 5%, then we can safely say that okay, the data subgroups are at different levels of performance. As we can see here, the confidence intervals for each city and each agency is separated from each other and they do not overlap. And even the p-value is less than 0.05 for both city and agency. So our interpretation would be that there is a significant difference between the city-wise ambulance reporting times, and even between the agencies that significant difference is existing. Since the response time is lower the better factor, we would check the means, and in this case we find that city 1 has got the lowest response time of 13.04 minutes. Similarly, agency A is at the lowest reporting time of 15 minutes. Box plot, if we have a look, that also tells that city 1 overall mean is lower than other cities. We can also note that for each city, agency A response time is less than that of B. So as per this study, we can safely infer that there is statistical evidence to believe that city 1 and agency A have response times significantly lower than others. Now in this example, since there are no overlaps between the confidence intervals, we can safely assume that city 1 and agency A performance level is better than others and it can be benchmarked. But as we said in case of one-way ANOVA, there would be many instances where the confidence intervals would overlap. And in such cases, we should not make the decision of benchmarking only by looking at the mean. And that is when ANOME or analysis of means comes into picture. I hope this video was useful. We would always be delighted to see your likes, comments and mails as we consider you an integral part of our learning endeavor. Keep watching this page as we plan to host more learning videos on concepts from DMAC, Lean, DFSS, re-engineering, theory of constraints, BPM and operations research. Please do subscribe to the page and keep receiving updates as and when we upload a new tutorial. Do share the links or channel details in your group so we end up creating a much larger learning community. In case you want us to talk about any specific concept, feel free to contact us. The contact details are mentioned here on the slide as well as on the page. So good luck and happy learning.